In this video, I'm going to talk about how to write the chemical formula of ionic compounds. It's really quite simple, but you need to know a few things really well, and that is, first of all, what are the ions? And that includes the charges of the ions. So in previous video, we talked about sodium existing as sodium cation, okay? And in the periodic table, magnesium, being in the second column of the periodic table, exists in nature as the dication, and so on. And way over here, we talked to how like fluoride or chloride are one electron short of having noble gas configuration, so they have things like that. And oxygen, being 2 electrons short of the noble gases, gain 2 electrons to become things like oxide. All right, and so we can just go ahead and fill a few things out. And so nitrogen is 3 electrons short, so it'd be nitride, and aluminum, for example, would be aluminum 3+. Okay, so the principle is that the cations have lost electrons and the anions have gained electrons. Well, if we're going to make a compound of cations and anions, you can think of it as these electrons that these guys took came from these guys, and the electrons these guys lost went to these guys. Okay, and so when we make an ionic compound, the total charge of the whole thing is 0. That's the key thing. So the first question we'll consider is, what is the formula for the salt? Okay, and so table salt is an ionic compound. That is to say, it's a compound made of ions. And so ionic compounds are frequently called salts. The salt is just a name for a generic ionic compound. Table salt is a very specific one. So that's the one we're going to do first. The salt formed from Na+ and chloride. All right. So we have 1 plus and we have 1 minus. Okay, so let's draw a picture. So we've got sodium. Now these ions are still round, just like atoms are round. And then chloride is Cl minus. The chloride is larger than sodium, much larger. And so the material is made out of the same number of cations and anions. Okay, now when we actually look at this material, there's not just a pair of these and then a pair of these somewhere else. That would be a much different type of material. Here, it's alternating chloride, sodium as a 1-to-1 ratio. Okay. Okay, and this pattern repeats in all directions. Okay, so it's just 2 dimensions, but it repeats in 3 dimensions. Okay, so because of this, there's no set pairing or arrangements of atoms in a cluster and then a separate space and then another set in a cluster. There is just these atoms in the form of ions, just adjacent to each other ad infinitum. So the ionic formula is the ratio, and so that means it has to be the simplest integer ratio. Okay, so I've drawn 3 and 3, so you think, well, that formula should be sodium 3, chloride 3. Well, that's wrong. Okay, what we do is we say, okay, we've got 3 and 3, the simplest ratio 3 and 3 is just 1 and 1. So the answer for the formula is sodium 1, chloride 1. We don't write the 1 subscripts, okay? And the subscript has to come after the element symbol. And note, we do not write the charge of the ion in the formula, even though it's an important part of determining what the formula is and your understanding that these are ions. So you need to get to the point where you see a formula like this, sodium chloride. You think, sodium, okay, metal, cation, chloride, nonmetal, anion. So I got 1 plus, because I know sodium always loses 1. I got 1 minus, because chloride always gains 1. And I know that I have a +1 and a -1, adds to 0. So that's why we have no charges written down, no overall charge. And we name it like an ionic compound. The way we name these things are actually different than they are for other types of compounds. Let's do another example. What about sodium and oxygen? Okay. Well, sodium and oxygen, sodium's +1, and oxide is -2. Well, these charges don't add to 0. Okay, you need another sodium. Now I have the same number of positive charge and negative charge total. So the formula has to tell me that there's 2 sodiums and 1 oxide. And I look at that and I say 2 to 1 is the simplest integer ratio, so this is indeed the correct formula. If I'd drawn a picture with 4 sodiums and 2 oxides, you'd think Na4O2, but the simplest ratio is 2 to 1. All right, now here's a little trick that you can quickly use to derive the formula. And that is, when you look at this, you can think of cross multiplying. The charge of oxygen is 2, the charge of sodium is 1. See how the charge of 2 makes this one have a 2, and this one have a charge of +1 has a subscript 1. All right, and so that will give you the simplest ratio. So I'll show you an example where this could be useful. So let's go ahead and do aluminum oxide. Aluminum 3+ and oxide. So now the simplest ratio will not have 1 of anything. The simplest ratio is actually 2 to 3. So aluminum 3+, aluminum 3+, oxide, oxide, oxide. So I have a total of 6 minuses, a total of 6+, Al2O3. See again, the charge of aluminum was 3+, and the charge of oxide was 2-. And notice how the 2 goes here and the 3 goes here. Okay, it's very tempting, for example, to try to put the 3 as a subscript of aluminum because the charge is 3. Well, that's exactly backwards.